before I begin, somebody asked a question with AI and tooling. I want you to mention this question again in the end. And let's start. So I changed the title a bit because I wanted to. The new title is Attackers Love Your GitHub Actions Too. Before we check the agenda in deep dive, let me introduce myself. So my name is Igor. I'm security researcher at OWASP Security. As Katya mentioned, I worked there for 2 weeks. Before that, I was security engineer at 𝐒𝐚𝐥𝐤. 𝐒𝐚𝐥𝐤 is an asset management platform, and there I was security engineer for 4 years. When I started there, I was the first security engineer. It was total chaos. It's a startup that grew very fast, and my first mission was, in the first 2 years, to make order in all this chaos, and my main mission was to automate all the SDLC, so I deep dive into all the world of SAST, SCA, DAST, secrets management, and secrets leakage, so very proficient with that, I hope. And after that, I was focusing on research and web penetration testing at 𝐒𝐚𝐥𝐤. Usually people present here hobbies, but I'm father for 3, so I don't have time for hobbies. And live in cybersecurity world, love it. We have also always something new to learn, and when we learn it, we need to learn how to break it, so in love with this world. The agenda for today will be, we'll first understand GitHub Actions to lay some common ground, and so we could be on the same page for everybody for the rest of this talk. This will be important to later cover the security risks that we see in GitHub Actions. Sorry, I have 2 computers here. And then we'll see the security risks that we will see earlier. We will see how they will demonstrate it in real-world attacks. And then we'll finish with hardening and security tooling, how we can be protected or mitigate the issues that we'll see in GitHub Actions. We can see reports that they harvested some statistics and stuff like that, and they found that GitHub Actions is in the 2nd place of most common CI tools by different parameters. Then came a different report in 2025 that already stated by Cloud Native Computing Foundation, if I'm not mistaken, that GitHub Actions already taken the majority of 51% of the CI/CD platforms. So very important topic today. So let's begin understanding GitHub Actions. GitHub Actions is a CI/CD platform built directly into your version control, and it gets triggered by events like pull requests, commits, pushes to the code. It can be scheduled or sequential events, many triggers that you would like. It's defined by, in general, actions can be think of like automation scripts that defined by workflows, and workflows are essentially simple YAML files, so it's relatively easy to control the actions itself. And as all CI/CD platforms, it automates builds, build, tests, and deploy steps of the CI/CD. We can see a diagram here that was taken from the GitHub Actions docs that it triggered by event. Each event, when it was triggered, it runs different jobs. Each job runs on dedicated runner. And in the job itself, there are additional actions and additional scripts. It's a bit like a spoiler alert to the next slides. So typically workflow is, as I said, defined by a YAML file. Let's call it CI/CD YAML file. Wow, this light is it's, flashing. Never mind. So the YAML file, we call it CI/CD. It has different components. The first component is pretty much self-explanatory. It's the name of the workflow itself. Later we have a trigger. As we said, it can be push to the code, pull requests, schedule or sequential events, and many more. And we have different jobs, as many as we like. If we will dive deep in the job itself, we can see other components, and each job runs on a dedicated runner. And since GitHub is acquired by Microsoft, you can guess that the runners are running on Azure VMs, just a cool fact. And each job has its own name, like names like can be build, test, as we said before. It can be security scanning and what the job needs to do. And it have, and it have also additional components. One of the components called runs on. it means it's the compute power that the LANL runs on. And the compute power, it also can be like macOS, Linux, or Windows, and it comes from different places. It can be GitHub hosted, and sorry, yes, it can be GitHub hosted by GitHub, or self-hosted. It can be your own private cloud, on-premises computers, and so on. And each job also has a part of steps, and each steps has also different components like uses. Uses, it's calls for other actions. I like to think about it when we call, sorry, it's confusing me for a second. The uses, it calls other actions, and the actions come from different places, can come from different places, like a marketplace. It's a marketplace of GitHub with a bunch of actions, around 40,000 actions that already has there. And it can be reusable workflows. Just to explain, distinguish the difference between both of them, like in the code world, we can write our own functions and our company will use them. That's more like reusable workflows, or we can call libraries from, for example, Python from PyPI, like already pre-made functions, and it's like more the actions of that comes from the marketplace. That's like the distinguish I love to think about it in my head. We have, if we continue with the components, we have another component in the steps. It's called run, and it runs scripts on the LANL's shell. Yes, and it runs directly, the run component runs directly scripts on the shell of the LANL. For example, you can run npm test or echo hello world and everything that you want. And that's continuous, so on and so on. We have step 2 that runs again actions, step 3, and so on. Now we come to a more, we can say a bit more serious part of the presentation. We'll cover like 8 security risks. So please be focused because I make exam after that. But just kidding, but it's truly important because we'll see after that real world attacks that use all these common security risks. So it's not just as it is, it's really important. The first one, security management failures. Yes. The first one is security management failures, and it's a big one. In 2024 alone, we had in GitHub alone around 40 million secrets that were leaked. And these scripts are often hard-coded in the code, printed in the logs, or not properly redacted. It's important to remember that those secrets are powerful. In GitHub Actions, we can call a lot of types of secrets, API accesses, make curl requests, or call other cloud services. As we see in this simple example, we are trying to log into Docker. And we see that in the first example, it's hard-coded, and in the second example, it's the proper example. It's been called from the environment variables as properly as needed, and the secrets are stored behind it in the GitHub secret encrypted store. And that's the first example. Jumping to the next, it's called insufficient permission management. It's a bit more particular case of the previous one. The previous one was more general. Here it's like to emphasize one special token called GitHub token. Yes. And I want to emphasize how much power this token actually has. The GitHub token is some sort of by default token that's used to communicate between your LANL and your workflow and your repository. It's used to connect these two things together and to deliver this communication. For example, pushing code, creating issues, or publishing releases. It's a very powerful token. Another cool fact, before some month in 2024, the default permissions was write permissions for most of them. And later GitHub changed it, the default permissions to be read-only. So we can see here a bad example and a right example that you specify the exact permissions that you need to perform the the action that you need to do. Another cool fact, Legit Security found that about 86% of workflow don't strict the token permissions. So most of the people don't pay close enough attention for this token. Jumping to the next, dependency pinning failures. Right. Yes, I need to multitask and I'm not good with that. Okay. Yes. Cool. Yes. So dependency pinning failures. When you use actions inside your workflow, most of the people, there's also other study that made, I think, also by Legit Security, that almost 100% of the people don't pin their dependencies. So the entire ecosystem is exposed. What it means that most of the people probably are familiar with that when you use an action, you pin it to a version or to a main. The correct and more secure way is to pin the action to a commit hash, because when the attacker, this is vulnerable because the attacker can alter the version or the main to point to some malicious commit, and then you are doomed. But if you check some commit hash and you understand that it's secure, you're already protected because the attacker cannot alter this commit hash. So it's good practice to do this. Next one is supply chain attack via compromised action. Yes, this is the example. A perfect example that we'll see in a few slides, that it's the TJ Actions compromise that was earlier this year. And it's talking about that you are, even with the pinning and everything that you do, you are not always 100% protected, because as we see in libraries in code, if someone familiar with that, and it's also true for here, when you use an action or a workflow, it uses different actions, and they use different actions, and this chain continues so on and so on. And eventually we need one action that was compromised, and it affects you. So supply chain attacks in action is a true issue that it's hard to protect against. Next one is one of the oldest tricks in the book, script code injection. It's true, I think, almost for every security field, that never trust user data that can be controlled by the user. Always check it. For example, here we see that event of the title of a pull request, it echoes to a command, and this is vulnerable. All you need to do is the title of the pull request, the attacker will use it and will write RMRF, and it's applicable to the code. The secure way to use the environment variables, not trust the user input, sanitize it, and everything that's true for code injection. Yes. Next one is artifacts poisoning. It's a bit similar in the idea to the previous one with code injection, but here we're thinking about it as files. This happens when workflows run artifacts from trusted sources. The real danger here comes when those artifacts, for example, file uploads from pull request, are executed in privileged workflow or a job that has access to secrets and all deployment credentials. So in this simple example, you can see that we download artifacts. There is on the left line AWS secret access key and some shell file that if you are not sure with where it comes from. Also, there's a chmod executable before that. If you don't know where it comes from, it can steal your secrets, and it's very dangerous flow. Yes. The next one is abusing the pull request target trigger. As I said, we have a different bunch of triggers. One of them is a very dangerous trigger called pull request target. Yes, I can say already, spoiler alert, in Orca we already found many vulnerabilities in the wild that using this pull request target trigger, and we actually reported CVEs. I think it's already published and will be published more stuff soon. It looks something like this. Wait, before that, I will explain a bit in general. The idea is when you when there is a workflow that's using this trigger, when you fork it, you use the secrets of the base repo. What I mean by that, when you make in a pull request, you can alter and use the secrets of the base repo from your fork. It will look something like this. If you have a base with the pull request target, it has a token, it checks out the code to the workflow itself, to the runner, with the 𝐒𝐩𝐞𝐚, very common, and you run some script from your repo. All the attacker has to do in this case is to alter to fork this repo, alter this script to something that looks like this, curl command that takes the token and sends it to some evil attacker site, and that's it. You will gain the token and wait, yes, and that's it. That's how you make this attack. The last one is self-hosted runner compromise. Okay, yes. In short, as we saw before, that you can use the GitHub runners, or you can self-host it by yourself. You'll also see a real-world example that when you host your runners, you need to take many consideration of security controls to yourself, like to isolate the network, make correct configuration, and only if you miss something, it's already can be compromised and attacked. We will see a good example for it in a second. So now we finish with the more tedious part, and we'll move to the real-world attacks. And we'll talk the most famous attack, the TJ-Action attacks that appeared earlier this year in March 2025. It affected over 23,000 repos, and actually it exposed around 218 secrets. The attack looked something like this. If you remember the pull request target that we talked a second ago, that's what the attackers did. They wanted to attack the TJ actions. They saw which other actions the TJ actions are using before that, and they came to they found the soft spot bugs repo. They saw that the spot bugs using the pull request target, and they could gain with this trigger of pull request target the secrets of spot bugs maintainer. This personal access token was applicable to different kinds of repos in the Spotbugs account, and this also personal access token was belonging to a review dog maintainer. And that's already the first step to a supply chain attack. Yes. Yes, and that's how they could gain the token. They gained the review dog maintainer's personal access token, and they could alter their workflow. When they backdoor the workflow of review dog, they waited for the TJ actions to use the review dog action, and when they use it, they could gain another token with this backdoor of TJ actions bot that had over permissive permissions of his token. And that's it. That's in general was the first vector of the attack. They pushed malicious code, and everybody that used didn't pin their dependencies to a hash, and they pin to a specific version, they will compromise because they already pushed the malicious code to TJ action itself, and they dumped all the memory of the runner and the secrets that appeared in the GitHub itself. They dumped it in the logs, so every public repo that used TJ actions, their secrets will dump to the public logs. Sorry, I need to drink. So that's the general attack of TJ actions. And before that, in the panel itself, the people said that defense in depth is really important. So here we can see that the defense in depth is really important here, because if somebody would have been protected by one of the security gaps here, he would stay safe. So the TJ action just used the 4 or 5 security gaps, and they made this attack successful. It's not so sophisticated, just some security gaps used together. The next one is is a CVE discovered by Felix Willem from Google Project Zero. The problem here was simple but powerful. The GitHub runner used to treat certain strings printed to std out like set environment and add path. They used to treat it as workflow commands. The result of this CVE that GitHub even deprecated is both commands. Just to show you a quick example how this attack, how they demonstrated this attack. There was a pull request title that coming to an echo command. All what the attacker needed to do is to put a pull request title with set environment to some path with a evil path, and then it was executed by the workflow as a shell command in the runner. So when you run after that in the workflow npm test, it runs from the evil folder of the attacker. Very sophisticated and easy attack that deprecated all those commands by GitHub. This is a good example for code injection via PR. Next one that we can see here is PyTorch. PyTorch is a machine learning library that maintained by Meta. Here, it wasn't here attackers, it was researchers from Praetorian. What they could make here, they made like a fix in the README and they got approved. They made a type of fix in the README, they got approved, and they suddenly become contributors of this library in GitHub. Once they become contributors, they could push a malicious workflow in a new PR, and because they hosted it a self-hosted runner, they could make persistent access because those runners wasn't deleting itself after each workflow run, so they made it persistent, and they installed another runner on this runner so they could evade EDRs and so on. And they could extract the secret, the golden secret of GitHub token. And with this token, as we saw before, you can push code to a repo. So that's what they did. They pushed malicious release to PyTorch, and everybody that used the PyTorch artifact was vulnerable. So this was researchers, not to attackers. So Praetorian gained for this bounty $5,000. And remember those guys because we will come to them later. Now for the hardening process, it's a bit self-explanatory, so I'll cover you this in like quick high overview of best solution here. So it's like a bit overused dead joke, but the best solution is to throw your computer to the garbage. But realistic solutions here are pin actions to commit chas, as we saw before, and not to versions or to a main branch. Use least privilege permissions. Use only the permissions that you need to perform the action itself that you are trying to perform. Use verified creators. I know it's a bit lame recommendation because you're not totally safe to use verified creators, but it still gives you a bit advantage over not verified creators. Never trust user control data. It's like in the cybersecurity world. Use environment variables in GitHub Actions. Very important to use for everything, for user input or secrets to prevent injection. Implement self-hosted runners security. It's in total the best practice. It's not to use it as much as possible, especially not in public repos. But if you already use it properly. Use infernal runners that auto-destroy themselves after each job. Require approval for all PRs, like we saw in Praetorian, that to fix one typo it's not enough. You need more harsh approvals. Use least privilege for GitHub token as much as read-only as you can. Don't go crazy with these permissions. Isolate your network from internal systems so they could not lateral move inside your organization. So that's for self-hosted runner security. Code owners, it's something that I didn't mention even once in this talk, but it's really easy topic. You just make code owners file in your repo, and and then every developer, for example, like you see here, if he wants to push some code to a workflows folder inside the organization, it requires a review by a security team or a DevOps team. So that's good security practice. Validate uploaded artifacts, treat it as raw data, never trust anything, validate it, and scan artifacts, any artifacts that you can with false secrets leakage. Now, it's the main idea why I started this talk and started giving this talk in conferences. It's I wrote a tool. Actually, in Axonius, they already changed it, and the previous name was 𝐒𝐲𝐴cchain. I really liked it, but they didn't. But they changed the name to 𝐒𝐴cspect, and the idea was of the tool. We had different actions that use other actions, and we was very secure company. We reviewed this manually, all the actions itself, and then we pinned it to a specific hash that was secure. But it was really tedious tasks, and we love to automate things. And the motivation was after the TJ action occurred, because we saw that nothing protects us in a good way from the supply chain of actions attack. And there are no good or static analysis tool that give you a good answer for this kind of attacks. They only can scan the individual workflow, but they don't go deep. So I analyzed tools, like much more tools that presented here, and started comparing. I didn't find an open source tool that gives answer for that. The most best company that I found that coming close to this is Endo Labs, but I was shocked that there is no one open source tool that gives you some help in this field. So some small guy thought about it, and he said, like, let's take the best existing tools and apply them just for all the chain and give you one consolidated report. So that's what I did. That's how the tool looked like. I used Zsmall because from all the tools that I tried, I liked this one because it had like less noise and it was dedicated for GitHub Action. I applied it on all the action tree. And also I used OpenGleb because it's a tool that I was really good with, and you can write on your own security rules for this tool, and it was really powerful and easy to control tool for me, and I think for everybody that is learning this tool. And when I run it on some repo, it finds 12 workflow files, for example. I run this tool on a workflow number 9, just to show you an example. And it gives me all the actions tree that are in my supply workflow. That's how I can say it. It always confuses me, like supply chain of workflows. And that's the results the tool gives. It shows you that the scanners that it used, the severities and the vulnerabilities that it found, and which vulnerabilities and in which depth. And it saves the report in JSON or HTML format. What eventually you see, it's bright, I know. You see all the severities that it found in which depth in the report, and the severities and the vulnerabilities or security gaps that it found. For example, here you can see unpinned GitHub action and where it found it. And that's it. This tool, it's like not like 100% cooked. It's like a prototype because it still requires a lot of time, and I didn't have this a lot of time, but it worked. I used this tool for a year. It helped me a lot in my job, and it was relatively good. Sorry, I bet I ran with my presentation today, but we're coming to an end, and I like to leave you with some homework. And OWASP always making an amazing job in every field that they touch. So they publish top 10 CI/CD security risks that I recommend you to learn about. And the guys from Praetorian that they found these vulnerabilities in PyTorch, they also made a conference talk in DEF CON, like the best conference ever, and they touched this topic very deeply, and they showed their GitHub Action attack diagram. It's a very interesting topic, very huge one. So that's the homework for you today. That's my contact if somebody wants to talk with me, and I would be happy to hear questions.
Igor, do you prefer to throw the pillow personally?
But Phil's the guy with the AI and tooling. Who asked this before? The panel? Wow, I won't follow you there, but I want to answer this question because as security engineer, we tried different, on one hand, I tried all the tools that are possible and that are in the SaaS, the CA field, and so on. And we started implementing AI. AI we implemented, we used the framework called cruise control. And what it did, it reported every PR the developers push to the code. The cruise control scan it and give us, like, if it finds something that is sketchy, it opens a Jira ticket. It also, we connected it to the GitHub and it scanned the code. And it was like the amazing idea. We were very excited, but it had like a huge noise. We tried to improve it for a year and even more. We improved it actually, but it's still, we tried to find like a common ground between the tools that we had and the AI because it still made a noise, but when it finds something, it was huge, great finding, and it required us a lot of time to review it. So the best thing that when I left, we used this both AI things and the tools in parallel because they completed each other. That's yeah. Yeah, I really wanted because it's like
Hello, hello. Thank you for the good talk. Pretty interesting. I would like to speculate a bit regarding, you're saying we should stick to commit hash, right? Not to the latest version. And let's just speculate. I'm not saying that makes sense. For example, I stick to the exact hash, and the next day it reveals that this version is vulnerable. Okay, and I am departed to the vacation, I don't know, and no one can fix this job. What to do in this case? Because if I'm using the latest version, I am expecting that the fix will be, I don't know, the next day, let's say. But if I am stick to the exact commit, it may be vulnerable the next day, and no one will find out it within our team, I mean, I don't know, in a week, in a month or so. What do you think regarding that?
Yes, it's really, it came a lot as a thing in my company. But fortunately, our developers don't like to upgrade stuff because it breaks their builds and code and stuff like this. And we just pinned the hashes after we check in like it's totally secure. We pin the hashes and then we like know that we don't need to worry about this action itself. When the developers wanted to upgrade, then we will upgrade with them together. We had like some sort of vault that we stored all the actions and the hashes that are secure that they could use. And if they wanted to upgrade, they just open for us a ticket and we'll scan it. I hope it's answered your question.
Okay, so the idea, you should be pretty sure regarding this commit before sticking it.
Yes, and we didn't use like the latest version or versions because it's less secure.
Okay, good, thank you.
Someone from the last row. Good, but I won't do it again.
Yeah, hi. First of all, thank you. You said it's better not to use self-hosted runners as much as possible, but can we blindly trust GitHub hosted runners? Should we take any measures when we use GitHub hosted runners?
Yes, I'm a security guy. I'm paranoid about anything and don't trust anything, but if you can choose one of both of them, self-hosted runners are harder to control and maintain because all the configuration that you need to take to consideration, and we knew that many people are not so sophisticated with GitHub Actions. Even we, as a security professional, it's easy to miss some configuration and be totally vulnerable, and GitHub just doing it for you. Like the same we can think as we use AWS Cloud, for example, or on-premises servers. It just, they worry for the security controls for you, for most of them.
Mm-hmm. But in case of self-hosted runners, like you control your environment, and in case of GitHub hosted, you don't have any control over it. Yeah. So that's the question: is if can we trust to something that we don't control?
Yeah, you cannot trust anything actually in this world, from my opinion. But it just from, as I thinking from security engineer perspective, if I need to approve it for the DevOps team or something, I will try to avoid it as much as possible. But because it's just hard to maintain and to miss some important security control. But sometimes you need just to do a self-hosted runner, and if you do it properly, it's like you're saying, if you do it properly, you can be quiet about it.
Thank you.
A quick one. Sorry, I'm just near him.
You flow to each other after that.
Yeah. You mentioned that you reported vulnerability in PR to target, something like that, when you fork and raise a PR. But have you proposed any solution for that, or just reported?
Actually, it's not the research that I was making, because I'm 2 weeks in Olka, but one of the guys in our team was making this research, and he found CVEs. And there is actually an easy solution for that. In GitHub configuration settings, you can just disable the pull request target option. It's so dangerous control that GitHub
itself
made this that you can disable it.
Okay, nice, thank you.
Thank you for very good talk, but I have a question. Are these tools paid, and how much they cost? And if it's small company, startup, should we buy these tools, or we can somehow use open source alternatives? Do you know such things? And you know, this is a question. When you're a small company, nobody wants to attack you. And when to feel that you're enough big company to buy such great tools and expensive?
Good question, actually. I liked my boss in Axonius. He was like 100%, like he told us everything. He told us the pricing and everything and all his stuff that he's thinking about it, where to put the money on. So that's why we released the 𝐒𝐲𝐤. It's like an open source tool for that. There are good, not bad stuff, like Dependabot of GitHub, that it's free for public repos, if I'm not mistaken, but still non-tool exists except what I know, what I wrote, the 𝐒𝐲𝐤 spec, they now call it, the open source. Besides that, no one of the tools are going deep in the supply chain of actions. But to scan the workflow itself, you have the Dependabot for public repos that it scans your workflows. It doesn't go deep, but still it gives you solution. All the Zismol that I used in my tool, I use it for all the chain, but it's also an open source tool that you can use for your workflow itself. It doesn't just go deep in the actions itself. So, yeah. And all the tools, by the way, cost a lot of money, so also you need to know where to focus the money.
Okay, hello. I have a question regarding public repos. Correct me if I'm wrong. So if you fork a public repo and run some actions, you will have access to secrets of parent repo, right?
Yeah, if they're using pull request target, I mean. Yes.
Okay, any secret, not only GitHub token, right?
Yes.
So how to prevent that? For example, if on some pull request we not only like verify some tests, but actually deploy to some AWS, let's say, and we have in secrets credentials to our AWS key and secret. So how to prevent that?
It's actually, I found it like half a year ago. It's the easiest solution that they have against the pull, what you are describing. It's relevant the pull request target trigger of the action. And I found just a half a year ago that I told this guy before that they have in the settings in GitHub that you can disable this trigger. And that's it.
And not to use this pull request at all.
Yes, it's relevant for specific DevOps task, but it's really dangerous trigger and should be.
But it's only for pull requests. So if you, for example, using some manual triggers or triggers by commit, so it won't be like that.
No, it's only for the pull request
enough,
target.
yeah.
You have pull request, but the target is the dangerous one.
Oh, pretty good. Thank you.
Ready?
No worries.
Actually, I wanted to address the previous question, is that you can also use identity federation with a cloud. So instead of storing static credential, you can actually federate the identity so that you will exchange your, for example, GitHub Action token for AWS or GCP access token, and then you can give permissions to only your repository, and actually you can limit it even to a branch. So that also gives a lot of options. I will talk about it more on my presentation because also covering that topic.
Because I'm not so sure about it.